Okay, I guess we can start. Hello, everyone. My name is Hewelt, and I'm a data scientist at Codilime. Today, I will share some work I've been doing at Codilime. I'm mostly working with LLMs, especially with those from OpenAI and Anthropic, so closed source. However, I also have some experience with open source, but today we are on OpenAI devs meeting, hence we will be using OpenAI models. Today, we will build a chatbot. So I hope you have your computers ready. It wasn't in the information, no? No worries, I'll show you step by step how to build a chatbot. I'll show you this is not very difficult and how to approach it. But before we start building a chatbot, I would like to remind you that this is not a new technology. I know everything has started with the inception of ChatGPT, because it was very innovative, very new, and it performed very, very well. It's still performing very well. But you can see the chatbot history started back in the 60s with the first chatbot, Eliza. Of course, it was very different than the chatbots we have at the moment. It was very straightforward, based on the prepared already questions, answers, and matching based on the keywords. And the important date might be around 2017 and 18, when transformer architecture has been introduced and the first transformer models have been introduced. And this is where BERT was created and the GPT-2, etc. This is like very first version of what we have right now, because these models, these large language models, which we'll be talking about shortly, are very advanced right now. They've been trained on a vast amount of data, and they can perform various tasks. Before, the approach was slightly different. We had one model for, let's say, translation, another model for text summarization, or for extracting keywords. Right now, we have those large language models which can perform a lot of tasks. And as you can see, I stopped here in 2023 with BART, but it's only 1 year after, and we have Anthropic, we have Llama, we have Mistral. These technologies are evolving like super fast, and that's why we are meeting today, and we are going to build something with these technologies. How to build a chatbot? We need few ingredients. First of all, we need a model. Model is the heart of the chatbot. Large language model knows the language, basically. So these models are trained in a way that they saw a lot of articles, a lot of books, a lot of websites, forums, etc. And they know language very, very well. On the top of that, they've been taught how to react to the instructions. So we have like a pair of question answer, so they know how to answer the questions. So this is high-level explanation. What is the large language model, or rather how it works? This is a very complicated neural network architecture, transformer architecture. We'll not get into the details. What we have to know, that this is a black box which knows the language very well and knows how to react to the instructions, knows how to answer the question. We are going to use, as I said, OpenAI models. We are pretty familiar, I believe, already with these models, with ChatGPT. ChatGPT is driven by models from OpenAI. That's the first ingredient. The second one, LangChain. What is LangChain? This is framework to build AI-driven applications. So this is basically the bridge between large language model and the application. So we needed to kind of like build these applications. And the last one, Streamlit. For those who are not familiar, this is a Python package to have a really nice interface, so we don't have to post questions in our terminal. We want a window where we can post the question and really nice formatted output. And this can be provided by this package. This is the standard package, but we want our chatbot to be domain specific. And we are going to build a chatbot for sales team. Sales team, because we are going to use the the resources which sales team are using. Is somebody from sales team here? Okay, we have one person, so we're going to show something for the programmers and something for the salespeople. This is the product for you, but we are going to develop it together. Okay, those are the platforms which are usually used by the business, by the sales team. So Salesforce and HubSpot are CRM platforms, customer relationship management, and Postgres database is just a database where we can store information about our clients, about our products, etc. So we are going to integrate those resources with our chatbot, and high-level explanation how the project architecture will be. We're going to create small chatbots, one to talk to the database, one for Salesforce and for HubSpot. We are going to create the small chatbots, and then on the top of that, we'll put an orchestrator agent, which is going to combine all these sources, so we can pose a question and get the relevant answer from all these sources. You following? Yes. Okay. How to approach it? We are going to use something called function calling. So basically, we are going to write function for each resource and then use LLM to call this function. Why this is a good solution for this particular use case? Because those three sources have something in common. They can change real time. So I'm going to shortly show you how these resources look like, how these programs look like. So we can just add a company, add a customer, add a deal, opportunity, and it is changing real time. So we need the most recent information in order to get it in our chatbot. You are probably familiar with RAG. RAG is retrieval augmented generation. So how it basically works, these two methods are to augment, to increase LLM knowledge, LLM, large language model. So again, large language model has been trained on some resources, some books, some articles, etc. In this particular example, I'm going to show you, we don't know what kind of books it was. We don't know what kind of articles have been used to train the model. It has some internal knowledge, and we're going to augment, enrich this knowledge. Because, of course, OpenAI does not know who is our customer or what is our deal or what are our products. We need to push extra data into this context, into this model-ish kind of, in order to get the information about our own, very own custom resources. And those are like two methods. RAG, we are getting the data, storing in the, perform some embedding, compute embeddings on the words, meaning changing the words into the vectors. Then we are packing into vector store, and we can quickly look relevant documents in the data store, vector store. Function calling, however, allows to pull the data from external system, from APIs. And why this solution is more accurate for this particular use case? Do you know why? Because the data changes. This one can be also used, but every time we would need to compute embeddings, which takes time. So for this particular use case, we're going to use function calling. And before we jump into the code, let me show you these systems. Okay, so basically, this is how HubSpot looks like. We have our companies, we have our contacts, here are companies. We also have some deals. And as you can see, it can indeed change real time. That's why we are going to use function calling. Salesforce, on the other hand, is also quite similar. We also have some opportunities. We have companies which are called, is it visible? Yes, which are called accounts in Salesforce. We have some contacts. Everything is sample data just for the demo purposes. Also, I would like to add that Salesforce or HubSpot are quite advanced programs, and there are even some kind of certifications for Salesforce in order to be proficient with this with this program. So why just not talk in the natural language with Salesforce, with HubSpot? It makes everything much easier. Okay, so these are those two platforms. Let me also quickly show you what we have in our database. Again, also very, very sample data. Not too, like the tables are not too big, just 3 tables. The database is not too big. Company representative, invoice, and company. I'm showing you these tables. I'm showing you what we're dealing with so we can pose relevant questions. Okay, so this is the data we have. And right now we can just move onto our code. I'm going to build 3 little agents, 3 little chatbots first. And as I mentioned before, on the top of that, we are going to build orchestrator. The first one we will be building with LangChain. I already mentioned LangChain, the framework to build AI-driven applications. So we are going to use LangChain to show you how to use already ready tool. However, HubSpot and Salesforce we built ourselves with OpenAI API. So basically what is happening here, of course, we need some credentials for our, can you see that? Is it big enough? Oh, light theme, sure. Do you know how to quickly change it? View. Shift. Okay. Just theme. Preferences, appearance. Okay. Dracula. You don't like Dracula? Oh, there we go. Yeah. Good morning. Hello. Okay. Is it visible? Should I make it? Okay. Better. Okay, so this is our end file where we store our credentials. So we need, of course, our credentials to the database because we are going to connect with that. We need OpenAI API key. On the next step, we're going to also need HubSpot API. Everything is, of course, available for in the developer tool. And Salesforce credentials. So before we start coding, remember to complete this one. Okay, so this is the first step. And now we can go to our code. So we start with the database as we are going to use LangChain in this particular example. After, of course, importing relevant libraries, we have to also get our credentials from the end files I just showed you. And right now we are creating our database. This is simple URL link with all the credentials in order to prepare database object. Okay, once this is done, we are creating our chain. So first we have to choose LLM. We are going to use large language model, which knows the language again, which is going to answer in the natural language. And once we have this ingredient, we can put everything together. As you can see, I am using here GPT 3.5 Turbo 16K. What does it mean? That means this is, of course, GPT 3.5 Turbo 16K, which is the context window. That means 16,000 tokens. What is that? This is the input and output tokens. Tokens we can simplify this into words. So 16,000 words, which are going to LLM. Input and output, altogether 16,000. I choose this one, this model, not GPT-4, the newest one, because it was giving me very accurate results. And 16,000 tokens for this particular example is enough for the database. Okay, once we have our LLM, we are building our SQL database chain. Just ignore it right now. I'll show you what is under the hood very soon. So this is already prepared by LangChain for us. We are putting all the ingredients, meaning our large language model, our database. Oh, this top K is how many rows we would like to retrieve. And here we are. We can already write our function. And the function is as DB agent. We're giving some prompts, template, which is basically, this is, I believe, the most important part. First of all, I'm telling my LLM that this is going to be Postgres. This is important because they are different SQL dialects. We are using Postgres. So I want my LLM to create correct syntax, which is correct code syntax, SQL, which is going to run this SQL query and give us the results. So let's say our salespeople attending this meeting probably don't know how to code in SQL. No problem. LLM will write the whole code syntax for us. Okay. And that's pretty much it. Let's run the query and let's pause the question, list my tables. Do you remember how many tables were there? 3, exactly. Okay, company, representative, and invoice. We have invoice table, so we can pose another question. What is my highest invoice? As you can see, we have our SQL query under the hood. It will not be visible in the final output, but we have our SQL query, which is, if you are familiar with SQL querying language, this one is correct. We are taking maximum amount from invoice table, and the highest invoice is $32,000. And we have the final answer in the natural language. We just built our very first little chatbot connected to the database. So what is happening under the hood? So there are a couple of tools already prepared by LangChain for us. And one of them is being Query SQL Database Tool. Input this tool is a detailed and correct SQL query. So this one is creating query for us. Another tool is Info SQL Database Tool, etc. There are 2 more tools, List SQL Database Tool and Query Checker, if I remember correctly. Yes, I remember correctly. Query Checker, so it is checking for us if the SQL query is correct. We have indeed actually description for each tool. So these tools have been prepared by LangChain for us, and we are simply using them by just putting all the components together and running the SQL chain. And right now we are going to prepare those little tools. We're going to prepare functions for different resources. So this is the database. Let's move to Salesforce. Okay, and with Salesforce, LangChain is a very powerful framework, and it provides a lot of classes, methods for us, for developers. However, it is not everything. It does not provide connection to all the available programs. And for example, it does not provide Salesforce. So we have to write the tool ourselves. And to do that, we are going to use simple Salesforce package. And we will prepare something very similar what you just saw with the database. Okay, so first we have to, of course, get our ingredients. We have to connect with this API, with the Salesforce. That's why once we have all the credentials, we can create Salesforce class with all the ingredients. Okay, and this package has very two powerful and useful methods, which is search and query all. Those are the methods. This is SOSL and SOQL language. So basically, SOSL with the search method is searching through all the resources in Salesforce by the keyword. SOQL, on the other hand, works like SQL. It creates SQL query because Salesforce is actually kind of relational database. So let's see how it works once we have our object. Let's try to find Google. I added Google myself because it wasn't available in the sample Salesforce database. So we should get some information about Google. And there we are. Okay, we have the company, not really with one opportunity. It is not very nicely right now, like we don't see much, but this is exactly what our LLM needs. And it's going to change it into natural language in the chatbot interface. Okay, the other method, query all, as I just mentioned, this is SQL for Salesforce. So we can put SQL syntax, select ID name from account, because accounts are the companies stored in Salesforce. And just like that, we got all the accounts, all the companies stored in Salesforce. As you can see, Pyramid Construction, Burlington Textiles, Edge Communications, etc. Those are all the sample data, all the sample companies stored in the Salesforce. Okay, so right now, when we know what methods we can use, we can just write functions. Two simple functions, executing SOSL and executing SOQL, where we are using the search method and where we are using this query all method. And once we have it, we created our very own functions. So as you remember, in SQL, we have a querying tool, we have a checker, SQL checker tool, etc. So our functions are execute SOQL and execute SQL. Maybe we can name it differently, not just execute as we are going to do that shortly. But this is exactly the same kind of tool we just saw in LangChain for SQL database. Okay, so once this is done, now we are connecting with OpenAI. This is from OpenAI documentation. So basically, using OpenAI API, we have to choose appropriate model. We are passing the functions which we are going to define for this specific tool. This one is automatically choosing the appropriate function. And this one very interesting parameter is the temperature. If the temperature is zero, it's giving us very deterministic answers. So when we pose the same question, it should give us the same answer. If we want our model to be more creative, we are increasing the temperature. As you can see, this temperature is quite funny. It is because we are using OpenAI API, and even though I put temperature to 0, I was getting different answers. So OpenAI in the background, this is a little con of these closed source models. We don't know what is happening under the hood. So even though the temperature was 0, I was getting different answers. And apparently, OpenAI indeed do some shuffling in the background. So what I read, not is just my assumption, actually a very good friend of mine from DeepSense sent an email to OpenAI to double check it, why the answers are not deterministic. They should be exactly the same for the same questions, but they indeed did some shuffling in the background. So I read on one dev forum that this little solution, in as much as it looks funny, it's giving more deterministic answers, than 0. Yeah, so this is one thing, and we are defining the chat function when we are defining the function. Yeah.
Something like beta type of C to make deterministic answer, but I believe that temperature is not exactly for deterministic. It's like a reach of words rather than deterministic or randomized.
Okay, yeah, so that is confirming this like little theory, and what we checked that the answers were not deterministic. So this is something you have to keep in mind while working with these closed source models, that you don't have like full control over your answers. So this is one thing. And the other thing is you can notice that I'm using a different model here. I was just using GPT 3.5 Turbo, 16K, and right now I'm using GPT-4. This is because I'm going to use this chat method to various classes. I'm going to use the same exact method for Salesforce, for HubSpot, and for the orchestrator, which is going to gather all the agents. That's why I wanted to have a model with bigger context window. Of course, we can change this model for every agent. But yeah, I wanted to have bigger context window, and this one has 128,000 tokens. So the previous one has 16,000 tokens. This one has 128,000. So it is much bigger. And also it is a little bit better with reasoning, which is kind of crucial when you have more than one source. And I'm going to use this one for the orchestrator, where I'm going to connect all the 3 sources. So I needed more powerful model, more better at reasoning. That's why I'm using this GPT-4. Okay, once this one is defined, we are creating our class, Salesforce agent. Previously, for SQL database, we have SQL database agent. It wasn't called agent, it was just SQL database chain. And right now, we are creating Salesforce agent. What we first are doing, we are defining system prompt and prompt template. So the difference between those two is system prompt is usually equipped with the roles. So this is the good moment to specify what kind of roles you are an AI assistant, you are a Salesforce agent, etc. I also added some crucial information for the task because as you probably noticed, or if I did not mention, so the companies in the Salesforce are called accounts. So I specify that accounts refer to companies and opportunities in Salesforce refer to deals, because in HubSpot we have indeed deals and companies. So I wanted these two to be in line. Okay, and the prompt template is giving a straight instruction, as you just saw in SQL database agent, that we have straight instructions like give me SQL query, run the query, give me the results. And here as well, and to understand the issue first, choose the appropriate function, straight instructions. Okay, and right now we are defining our functions. So in OpenAI API, we have these 2 parameters, available functions and just functions, or available tools right now and tools. And here we are describing what we are dealing with. As you remember, in SQL, we have this query checker, and there was the whole description, and we also have the whole description here. Of course, we can enrich it, we can write something more, something less. I just simplify it to execute SOS, SL, and SOQL. Okay, and that's pretty much it. We are defining the chat method into that class, and we can talk to our Salesforce agent. For example, list my companies. Notice that I'm using companies, I'm not using accounts. So to double check if my what? System prompt is working well. Okay. And we have all our companies. Have a look that we have 14 companies. Let's try and add the company right now. Accounts, new. Let's just add company, account name, example. And let's pose the same question, list my companies. And this is the con of having a function calling. Oh, there we go. We have example just freshly added. That would be impossible with RAG because first we would need to compute the embeddings on the newly added companies, newly added resources. That's why function calling is a good idea for this specific use case. Okay, so this is our Salesforce. We can move on to HubSpot. And the idea with HubSpot will be pretty similar. We're just going to use different API, HubSpot API, where we need to, of course, provide our token to HubSpot in order to connect with that. And just based on HubSpot documentation, we can see what we can retrieve from there. So we can, for example, get all contacts, get all deals. Let's see how it works. It's pretty nicely formatted. Get all contacts, and apparently we have one Luis Gonzalez, Tim Goyer, etc. We are getting all the contacts from our HubSpot. And again, this is not a very nice readable way. Of course, we know how to read it. We see everything like first name, last name, etc. But our LLM will take this output from the function and put it in a nice words in natural language. Okay, here we don't have simple tools like SoQL and SoSL. We have to write functions for pretty much everything. So get all the contacts, companies, products, deal owner, deals, etc. I already wrote these functions, so we are not going to dig really into that. We can just see that it is working, get all deals. Also, I flattened these functions. I just put them in the list, so it is easier for me to work with it later on. And that's pretty much it. We can already create our HubSpot agent class, which we are going to use the same chat function from the previous code. And again, we have our system prompt and prompt template, the specific instructions, what to do, how to fetch the data, what kind of data is available in HubSpot. And again, specifying all the functions available for this particular tool, for HubSpot tool. Some description, and we can post questions to our HubSpot. It's exactly the same method. Let's just do list my companies again. Of course, we can ask any question like list my deals, list my open deals, or anything. I just put it in the loop. That's why I have to put. Okay, those are the companies, and indeed there are 4 companies in HubSpot. And that's it. Now, when we have all the ingredients, we have all little chatbots. We can already chat with database. We can chat with HubSpot and Salesforce. We can put orchestrator agent on the top of that. And this is, again, pretty straightforward. As you understand, I hope, the previous methods, right now it is actually the same thing. So we are importing all the functions. We are putting everything into one big function. So all the tools for Salesforce, for HubSpot, and DB agent. And once we have it, we are doing exactly the same thing. So we are writing the system prompt. Right now, we have more than one source. So I specify that go to all the resources, give me the information from all the resources. There are different identifiers in different resources. So take this into account. So make sure that you just check it. Also notice that some prompts are emphasized. This is a really nice tool. Like if you're doing prompt engineering, so this is a really nice way to emphasize some commands in your prompt. Okay, and once we have it, we have our system prompt. We also have prompt template a little bit further. I'll show you in a minute. We are specifying, again, our functions accordingly with OpenAI API, and creating prompt templates, meaning giving straightforward guidelines to our model. And that's it. And this is how Orchestrator is computed. And right now, we can move to our app. This is our main function, get response, which we are going to pass to our Streamlit application. And the application, it looks like that. It's pretty easy. We just putting some title, chatbots, and we are going to create text input window where we are going to post our questions, and using get response function from our orchestrator, we are getting the answers. And this is how it looks. It is pretty simple. I'm sorry, like I didn't put any emoji or something. We have our chatbot, we have our little window to post questions, and we can start posing questions. I already put one, list my open deals. We can ask who is Frank Harris, for example, because this person is in both HubSpot and SQL. I know that because I've been working with this data, so I'm just telling you this person is not in Salesforce, so we can see in the output how the LLM will read it. In the background, we can have a look that we are already asking these questions. We are running SQL query in the background, looking for Frank Harris. We got his details. Apparently, he has one deal in the SQL database. We also ask Salesforce and HubSpot. Let's see if we already have the response. Yeah, Frank Harris is contact associated with company in HubSpot. We have some details in SQL, combining data from all the sources. Frank Harris is contact in HubSpot, associated company, etc. There is no record of him in Salesforce, which is correct. Okay, and this is how it works. This is how we can combine all the resources together. That would be it. Thank you very much. And if you want to ask any questions or stay in touch, this is my LinkedIn, so we can connect. Thanks.
Or you can ask them now.
Or you can ask them now.
But let's do it through the mic so that the others online hear.
So I think I missed the part where about the exact flow of the prompt. So we ask the question and then we get this multiple agents. I also saw prompt that's I think chain of thought reasoning, right? Like explaining the chain of activities. But which component does which? Where does the prompt go, and how does it aggregate the results from the different agents?
Okay, so the prompt here, let's just move on to the orchestrator. Will I see the, okay. So it is all here. We have our chat methods where we are getting our prompt from prompt template. We are getting all the messages. This is where we specify role and message. We are getting all our available functions and functions. This is the framework from OpenAI API, and that's pretty much it. And how it works, let me show you. So I specified in the system prompt that, and this is also in this method chat. This is this one, function called auto. So this is automatically choosing which function the model is going to call. In as much I specify, do the cross-check, check all the sources. So it is calling all the functions. So this is what is happening in the background. I left the little printing. I know this is not clean code rules, but I left little printing. So we can see that it is going first to HubSpot agent, then to the Salesforce agent, and then querying the SQL chain. And then this is how we are getting all the responses from all these agents. And here SQL chain is printing what is happening in the background, because this is already ready tool. I did not include that in our solution for Salesforce and HubSpot, and this is it. Once we have the output from all the functions, because I want this model to do the cross-check, even if this is actually specified in the prompts. Even if we don't have an answer from the particular function, please just tell me that there is no such information in this particular source. And once we have all the outputs, the LLM is computing the final response.
Are these separate calls?
Yes.
So our query goes to the orchestrator agent. It executes the functions. It gets the results. And is there a prompt template that this results get pasted into, or does the orchestrator agent kind of execute a second input-output operation?
I believe the second one. I believe this is like native for OpenAI API, because this is not like I'm gathering right now somewhere these outputs.
Okay.
So yeah.
It seems like it resides or happens somewhere in the chat object, right? From
yeah, it's here. It's specified here.
Mm-hmm.
Yeah. So this code is a little bit more advanced. It's not just, this is the most important part, obviously, but what is also happening here, I can share this code with you. It is also, I had some problems being looping. The LLM was looping because sometimes it did not find the result in a particular source. So it was calling the function and calling again as long as it get the result, but the result wasn't there. So it was specified in the prompt that, hey, if there is no result, just come down. There's no result. Just give me the information that there is no information in this particular source. But yes, I believe everything's happening here, and this is native for OpenAI API.
Thanks.
Thanks.
Question in the background, running with the mic so that you're audible online.
Thank you. How would you handle the data privacy here? Because we all know that Salesforce data and HubSpot data, that's very sensitive deals,
Yeah.
personal information.
Okay, yeah, data privacy is a big concern right now. And I'm not dealing with privacy, to be honest, in this particular demo, because this is sample data, this is not client data. But as you can see, there are like deals, there's money involved, there are companies, details about our customers. So probably we don't want this data to be sent to OpenAI. There are a couple of solutions. First solution is to sign NDA with OpenAI for them to not use the data for training purposes. Second one is the package called, I believe, Presidio, to anonymize the data before it goes to LLM. So we basically masking some data. It goes to LLM, and in the output, we are opening it again. I've never used that. I heard of that. And yeah, those are the solutions. And the third solution would be to use a different model.
Azure OpenAI.
Azure OpenAI. Or just, open source models get locally, and then you have like full privacy. Yeah, this is the ongoing topic with the privacy. But yeah, right now the AI landscape is still evolving. So I believe right now the good point is that we are getting all the knowledge possible. We are building applications, and those regulations will be introduced sooner or later. AI Act is already there, right? So did you read it already? Not yet. It's a long one. Not in Poland. Not in Poland. Yeah.
The Polish government didn't do
the job.
The job documents to make it like Polish law.
Okay.
It's only like European law, which doesn't exist in Poland yet.
So there we go. Like it's still evolving, especially with those regulations.
Yeah, I had a question about Assistance API. I don't know if you've played around with it, but I think it makes it a lot
Sorry, I cannot
easier.
hear you. Yeah, louder.
Right. How about now? Is it better?
No, like the microphone doesn't work. It works for YouTube.
It works for online.
Yeah.
All right. Yeah, I had a question about the Assistance API. Don't you think it's sort of the same, what we're doing here, but in a much simpler way? Or I don't know if you've played around with Assistance API, which is a new API.
Yeah, I haven't played with that.
Yeah.
And also, this is the code I developed quite some time ago. So this is the solution at that point of time.
I think I can answer this question. Assistants are much simpler in LangChain. I think I can answer this question. Assistants API can give you the ability to do much simpler tasks that like one chatbot can do. And in LangChain, you can build basically what you want to build, like many steps, multi-chain agents, etc. So if you want to do something simple, like one chat with few functions calls with some retrieval augmented generation, you can use Assistants API or the equivalent on Azure. But if you want to do something tailored for your specific needs, I don't know, multi-step reasoning, etc., you can use LangChain or other stuff.
And here I would like to add the comment about LangChain. So you saw the two solutions, one with LangChain and one written from scratch. The reason is LangChain is, of course, a very powerful framework, and we love it. However, there's a lot of hard-coded things. And as you can see, like when we were coding Salesforce and HubSpot, we had full control of what tools, what functions we have. We knew everything what is behind the scenes. And LangChain, of course, it's open source, so you can dig into that. But this might be a little tiny bit limitation.
Maybe let's make it the last question.
Okay, so about data privacy, I thought about some thing like placeholders. For example, if we search for a name and the surname, we could have in the database something like a nickname for every name, which only we know in the application. So, for example, if I'm Dominic and I want to search about Dominic something, it changes to Balder, etc. And in the GPT there is a Balder, and in database there is a Balder, but at the end the application changes again Balder to Dominic. So we give away data, but it's a bit randomized and fake data. So my question is it a way to make it more secured, and is there any issues about the, for example, cost of or operations of that idea?
So again, I'm not sure because I haven't really worked with that, but I believe this Presidio package deals with this problem. I'm not really sure how you spot this very sensitive data in this package, but if I can recommend something, I would say Presidio to check further how it really works.
Kasia, one question from online. Do you really love LangChain? Why? I didn't have much experience with LangChain, but documentation is very chaotic in Python. Also,
Well, good
many
question.
examples are outdated. Would you agree or deny?
Okay, LangChain is useful, and it makes our life easier in many cases. But no, I do not love LangChain. Sorry, that was overexpression. It is really new tool, yeah. Yeah, it is various problems. It's a new tool. It's still open source. Everybody's working on it. It's evolving. It's developing. It's getting better. But yeah, there are still some limitations. That's why we did our own solution from scratch.
Just last question from online. Temperature parameter was set so low to make the response more deterministic?
Yes, exactly.
Okay.
Yes. Yeah, well, in this particular use case, I don't want my model to be very creative. I'm not summarizing, I'm not writing any stories. I just want to get the data from the sources and give straightforward answers.
Thank you, Kasia.
Thank
A
you.
big round of applause for that story. That was wonderful. Well told, very simple language. That's what I really like, to share the knowledge in such simple words once the story is not that simple. Now let's have a break.